and it is very effective for the first and second phase of the disease without any sense of gravity. Among the strategies is also the vector control with specialized follow-up of patients and reactives. As we all know, the logistics for the treatment of the second phase of HAT is very heavy. One box of NECT can only treat 4 people, and the treatment is also binding both for the health agents and also the patients need a lumbar puncture and for treatment, without talking about the period of time to take at the hospital. There's also stigmatization when he goes back home in the village. Given all these difficulties, it was necessary to find a molecule which is effective during the 2 phases of the disease and with less adverse effects. With the progress in research, finisacdozole and acabarol have been developed. Azacabarol is still in the phase of development. Fexinizole is being used since 2020. All these are oral treatments and 10 days of treatment. They are very effective during the second phase, 2 phases of the disease. And there's no need for hospitalization. The objective of our study was to contribute to stopping transmission in the 3 endemic foci of Guinea by 2020. By 2030, we have to determine the level of knowledge, perception, attitude, practice of investigators on the sleeping sickness. Here we have a picture of the site of the study. The 3 endemic foci. The cases which have been screened. We carried out an analytic study, transversal, a mixed approach, qualitative and quantitative approach, on the feasibility of the introduction of new treatments against HAT in the endemic foci of the countries. And that's why we had to avoid to go back to the same history. That is the issue of distribution of some drugs in medicine in the school. There are some children who took this medicine which brought them some problems, and there was the community which was not happy about it. So there was need to study the population before giving them the treatment. For the quantitative approach, we developed a questionnaire where the former patient and their close relatives were followed. We also organized interviews, semi-structured interviews, with the focal points of the 3 endemic foci. And focus group discussions were organized for the patients treated with the former treatment and also for patients treated with the new medicines. The size of our sample was 422, both patients and their close relatives. For the qualitative approach, there were 3 interviews, 1 per household, and 2 focus groups, 1 for the sick with the patients with the old treatment and 1 for the patients with the new treatment. And Now, regarding the results of our study, results on the treatment for oral treatment of primazodial found out that 50.2% of our subjects, our respondents, have heard about that treatment, and that was through the mosques and through health agents. More than half knew at least one treatment center. The results of our studies on perception and attitude regarding the oral treatment of HAT, almost all the respondents was accepted the treatment, and said it should be encouraged. The results on treatment of HAT. Regarding the question to know where the respondents would go when they have fever, more than half said they would go to the health centers when they have fever. Then the question to know how the community treats HAT. Half of the respondents said that they treat that HAT with modern drugs. But there were obstacles which were observed on the issue to know what would stop them to go to the hospital. The difficulties of transport, the cost of hospitalization were noted as the causes. The results of our study concerning qualitative data showed three tendencies. There was the first group which was favorable to oral treatment of HAT, the group which prefer tablets so as to avoid lumbar puncture. Another group was in favor for injections. For them, the injections reacts faster than the tablets. Then the third tendency, which said that doesn't mind the type of treatment they get, but what is important to them is the getting cured. The results about knowing the knowledge of health service providers on the treatment of HAT, oral treatment of HAT. They participated in clinical trials regarding this drug, but they had also shared mixed feelings concerning distribution of these medicines during the campaigns. Now, in conclusion, we can say that geographical, financial barriers, even the lumbar technique, which is painful, are actually factors which affect the adaptation of the new treatment in the three foci will depend on good sensitization. However, a study is also a study has to be extended to other health sites in the countries, and also to other people who have not had the HAT, and also no relatives who have had HAT. The analysis on factors which have influenced the introduction of this molecule is still underway, and as soon as the results are available, we shall disseminate them. Thank you. Thank you, Dr. Mariam. The next presenter is Ginjas Ngolo, who is going to talk to us about access to Phoenix in the context of the COVID pandemic in DRC up to December 2021. 10 minutes. Thank you so much, Mr. Moderator, and thank you, Mr. Chairman, for having given me the floor. We are going to talk to you about all that we have done during the COVID period in the DRC for treating patients of HAT. As you know, the small history, flexinidazole is the first oral medicine which treats HAT in the two phases, whether the first or second phases. In 2018, the European Agency on Drugs had the approval, and then we had the approval, and it was also the beginning of the COVID pandemic. We had to treat the patients all the same. I would like to thank all the collaborators who were here and those who were not able to come here. So that's our plan of presentation. As I said, this is a medicine which is taken orally and which treats both stages. It's given for 10 days, but we have to say that it can be given at home, not only at the, but it has to be supervised by a health agent. What can we say regarding this product? There are advantages and disadvantages. Among the advantages, the oral treatment is easy to administer. We are taught to say that we need a whole here. It is easy to transport the 20 kits even in an area which has difficulty of access. It's easy to administer and also easy to conserve. There's no bitter taste, so it is easier. But here we have to say also that with Fexi, we can or may not do lumbar puncture. We shall see when we can do or not do the lumbar puncture. But there are also some disadvantages. In case of vomiting or in case of coma, we cannot treat a person suffering from HAT with flexinidazole. How did we proceed during this COVID period? After the training that all the colleagues of the health benefited with the help of WHO in Kinshasa, now at the level of at the national level, we had to go to the provincial level and go on with the training. All people have to be trained. All the health agents have to be trained so as to be able to administer flexinidazole. You can see this card, this map. In yellow, these are general reference hospitals. In blue, the center of reference. The red ones are health centers where there are no medicines. In a reference health center, there's at least a doctor. As you can see, there's a concentration to the west of the map where we have a lot of health reference center where the people have been trained for flexinidazole and also trained in diagnosis. You will also observe that there were 96 in total, 171 for all the health centers which we trained, but the majority were general reference hospitals, which was 96 people trained. Here we have the guidelines of WHO, which helped us a tool for training and how to explain how to treat cases, because it's not the only molecule, there are other molecules. So if you observe well, we don't give to children of less than 6 years and having less than 20 kilos. And this possibility after 6 years and more than 20 kilos, you can give them. But for any patient who has white blood cells of more than 100, you first use less than 100, use next, and then Flexi will be the second choice if in that health center the neck is not there. But for any patient with a figure less than 100 white blood cells, and for HAT gambiensis, these three molecules which have shown there, there's L-flornithine and fexinidazole. Fexinidazole is now doing a bigger role amongst the molecules which we're using now. If you look at the algorithm of the management which WHO gave for training the health service providers, so when we use fexinidazole, we don't have to do lumbar puncture. We only do lumbar puncture if it is so serious. If there's a case of the service provider can do lumbar puncture when those serious cases. But if the sense of neuropathy is not there, then we just only give fexinidazole, and then we do follow-up visits according to the program. The results which we were able to obtain during this difficult period of COVID pandemic shows that if you look at the red figures, tomorrow we shall give is the big coordinations of Kasai or Bondudu, where there were many cases treated by these hospitals, and there are only 2 hospitals who treated most cases of HAT with fexinidazole. At the level of health centers and hospitals, there are 72% where patients were treated during this period, 2020 to 2021. We want you to observe one thing here. During this period, between 2020 and the first quarter of 2021, at the level of the program, there were 472 cases, and the adoption of Fexi was in December 2019. That at least there were 291 who were available for treatment for fexinidazole in the DRC. There are some conditions for being treated on fexinidazole. Among the 159, there were some which had been treated with Fexini, and that's why we had 132 which was treated with this period of COVID with fexinidazole. So during the COVID period, they were able to treat the patients with fexinidazole. So what can we say there regarding this problematic which we had in the country? It is true that we can have some epidemics, and the lesson to get from here is that COVID-19 brought a lot of changes into the country. There were restrictions which we had to respect, but we tried to adapt and the activities, and we tried also to decentralize some activities. And the lesson here is that yes, effectively, during an epidemic, we can now see how we can take decisions and how we can have an approach which is appropriate, and also we have to better organize services so that during a pandemic we continue providing services. Thank you for your attention. The next presenter is Professor Enoch Matovu, who is going to talk about the perspective for the introduction of fexinidazole in the treatment of HAT.
Good afternoon. I'm here to present on behalf of who has not been able to come. You can see we are a very big team. Several institutes, IRD, VEL is here, Tropical Medicine in Lisbon, and Swiss TPH, National Control Programs, and Makerere University. I'm presenting about fexinidazole for Rhodesiense, just to give you some background. How do we move it? Okay, next slide, please. Yes, this was the landscape in the beginning that since 1949 is when we had the newest drug for late stage sleeping sickness, which was published, first used by Friedheim. And so there were advances that brought in new drugs. NECT came in, fexinidazole came in, and we have already also heard about the supposedly silver bullet oxaboro. But these, unfortunately, they were all meant for Gambians. So you see that Rhodesiense became a most neglected entity as far as treatment is concerned. So we went ahead to get this project, which is HAT-RAC. HAT refers to Rhodesiense and was about increasing access to treatment diagnosis, but towards an arsenic-free treatment for Rhodesiense. We're a big team, as I've already said, overall led by Olaf, who is not here, and we had the coordinators, Charles Wamboga, the moderator who will answer most of the difficult questions. Marshall is also here, and we had two sites. So the whole idea was to extend indication of Fexi for treatment of Rhodesiense to ensure proper execution of a clinical trial through training. That was a different work package, and also to engage the community, increase awareness about Rhodesian sleeping sickness. We had two sites in Uganda, one in Ruala in mid-north, and another one in Rumpi district of Malawi. So particularly today I'm presenting about the clinical trial where we wanted to see the efficacy, test efficacy in patients with Rhodesiense. The aim here, I wanted to show that Fexi could offer an alternative over Merazopro for stage 2 heart, and even over Suramen for stage 1 heart, because to date only those two drugs are available for treating Rhodesiense. So we carried out a multi-center open label clinical trial in Uganda and Malawi. We recruited 45 patients, of whom 35 were in stage 2. Recruitment happened over 26 months, and we're doing follow-up for 12 months post-treatment. Here, it shows you how patients accumulated over time. In the end, we had 35 stage 2, but of which 34 were evaluable. But in total, we had 45 because we also had 10 patients who were in stage 1. And this is a distribution of how they were. Stage 1, the majority were stage 2, more men than women. And we also had children in the collection, distributed as you can see here below. So of all this, there are only one screen failure where the person screen didn't proceed. 44 patients completed treatment. We had one relapse at week 9 who was successfully treated in Merazopro downstream. We also had one death to during treatment. There was one pregnant lady who was in the 3rd trimester that was also successfully treated. We didn't include any breastfeeding women. Now, the results here, secondary and primary endpoints, the whole idea of this clinical trial was to show that FEXI is not inferior to Merazopro, and we are using available data on sites where it happened, because it was difficult to get a big samples, big numbers of patients to obtain sample size required. So we did this comparing to historical results of Merazopro treatment. So we showed the primary objective. We wanted to show that the fertility rate is not higher than for Merazopro. So we determined that at 8.5%, anything above 8.5% fertility wouldn't be acceptable. So here, what we see is that we didn't have any death related to treatment. So that one, we achieved it. The second objective, we wanted to show that failure rate should also not be above 12%. Again, basing on what is known in the case of Merazopro. So we had only one relapse, which was about close to 3%, much less than the unacceptable rate of 12%. So also there, we made success. Now, looking at signs and symptoms, you can see the majority were fevers and headaches, but as you can see here, already at the end of hospitalization, they had gone down. They had virtually, largely disappeared, and this is at the end of follow-up. Again, we had just a few headaches, a few headaches, just some, and some other events. So here, in terms of adverse events, they are mainly gastrointestinal disorders, vomiting, nausea, gastritis, and a few of those were related to the treatment itself, but we were quite few, and they completely resolved with by the end of hospitalization. We had others like in ECGs, others, and for example, there was this acute renal failure, which was the cause of the patients who died during treatment. And so the DSMB studied available data and established that it was not related to treatment. So we continued. During the follow-up period, we had a few adverse events like pneumonia, urinary tract infections, which were handled accordingly. So we had also training activities, training the technicians and the clinical staff on how to handle in Malawi and Uganda. Community awareness, we did the ethnographic studies, and we have so far from manuscripts that have been being prepared. These are some of extracts from the social science component. This IC material, this is in Tumbuka, Malawi language. And this is for Uganda. It is in English, but we also have translations in local languages in the area where the clinical trial was carried out. It's now stuck. Yes, so the present situation is that dossier has been prepared. The final clinical study was available by June, and we closed the clinical trial 18th June, and we presented the results of the trial in both Uganda and Malawi, and they were quite happy to receive them and the ministries of health. So conclusions, so the primary objective has been achieved. We have shown efficacy that is not inferior to Merazopro. Patients were improving already by day 5. It was clear that they were on the positive recovery path. Safety also favorable. PK, we took samples for PK, and it has been used to also to get a final profile, which had been already established from Road of Gambiense. We did LAMP and PCR on DNA and cDNA as tests of cure, because we were worried about a patient relapsing and us not being able to quickly detect. So they have proved useful in that aspect. The relapse that happened was a real relapse because we didn't see a difference in strains when we did the microsatellite analysis on the samples before treatment and at the relapse. So dossier was submitted in May. The WHO might prepare updated treatment guidelines after the opinion of the EMA, because right now actually Olaf is in engagement with EU EMA, Medicine for All, so procedures to go on so that we can get a scientific opinion. Then subsequently there will be registration in Uganda and DRC, followed by approval for use in the remaining countries. So I want to thank all those who participated in clinical trial, both the patients and the national control programs and other participating institutes. Thank you.
Thank you, Professeur Matovu. La prochaine présentation était...
Thank you, Matovu. The next presentation is the efficiency of this trial clinic. So I don't know who is going to present that. Dr. Makaya is one of the investigators in this study. You have 10 minutes to do your presentation.
Merci, messieurs les modérateurs, pour m'avoir accordé la parole pour faire cette présentation. Je suis Dr. Makaya.
I'm Dr. Makaya, investigator of fluxinilazole in the province of Bandundu, and I'm going to present you this work which was done in our different clinical hospitals. It is about efficacy in patients who are affected in Gambiense. So it is a study multicentric, open to one hand, about the phase 1, 2, and 3. Talking about that molecule, you have to understand that it is a molecule which belongs to benzosa, and it is a product with a wide distribution, and it is connected to the protein which goes through the skin, and its life is about 16 days, and it is given just in one dose. Talking about the history of this molecule, so you have to understand it was identified by the trypanosomias in Gambiense in the Center Sedler, the University of California in America, and the innovation by two societies in agreement, and one of the university in America. And at the end of 2009, they had also a program of optimization. And in 2011, they had also a development for the study in a clinic. And in 2012, it started also in France. Finally, it was in October 2016 that now the test started in site. It was the second and third phase, and this one took place in DRC, Congo, and Guinea. Talking about the population of this study, so we had also to screen 260 patients who signed. So from this patient, 51 who didn't fill all the criteria to be included in this study. And there were also one who died before the treatment. So we had also to take care 280 patients. It was the 41 a patient who was at the beginning of this treatment. And the others were now at the state of the disease. Finally, after the follow-up of 18 months, all the patients concluded the treatment, especially those who started and who are also at the intermediary treatment. But the patient who was at the second stage, so we had also 160 who concluded this follow-up. And you see that, okay, some were in fact died, and because of the coming up again of this disease. So it was the study which was at the second stage to test the efficiency and security by the patient who was affected. The population of the who were in study, so it was between 15 and above, and we had also to make a follow-up of about 60 and 6 sites, and the others in DRC and another in Guinea. So as we said, there were 208, and we visualized the presence of parasite and video and camera. So we had 41 in early and intermediate stage, 167 patients. The follow-up, the result of the success, treatment success rate at 18 months in stage 2. The percentage was about 95%, and at the conclusion, without removing what was excluded, we had about 98.1. So the 2 stage, it was 100%. So we had also 4 who died, and it was not connected to the treatment, and 3 cases of now re-emergency. You see, about the improvement about these cells. Here you can see this table which is trying to evaluate the parameters. On the other side, we have this table giving us the idea of the sign that the patient had from the beginning. So there is a big percentage. It was now the cephaly, and the cephaly at the beginning it was 62, and after the treatment, so it went down. After 15 days after the treatment, so it was around 4%, and the last visit, there were no also signs. Talking about the effect, the side effect, most of the side effects were not connected to the treatment. So we are going to see the disturbance of the nervous system. A big number of patients also reported about it, and also the one of the stomach. So we had also a lot of side effects, but most of them they were not connected with the treatment. Talking about the results, about other safety results, safety laboratory results, and also hematology biochemistry, no significant change from baseline in hematology parameters. No significant change from baseline in ALT and ST, whatever the stage. No significant change from baseline in other biochemistry parameters, whatever the stage. Thyroid function test, no clinically significant abnormal value. And then after the treatment, there were no anomaly value. So we had also to do other tests, but there were no big difference before and after the absorption of also the medicine. So slow rate of absorption, it was 229. Talking about the side effect overview of serious adverse event and pregnancy, we had 27 for 20 patients, but it was not related to the treatment. 4 fatal cases, and they were not related to the treatment. And 1 before study drug administration, acute fulminant hepatitis. And we have also tuberculosis, progressive ascending peripheral neuropathy, post-surgery acute pulmonary edema. All these side effects were not collected with these medicine. So we had also 12 women who are also pregnant. And others, one of fatal death, 2 neonatal death. We succeeded that 9 normal deliveries were normal, and we didn't have no congenital anomalies. In conclusion, what we can say about this molecule: high efficacy in any stage of HAT, favorable safety profile, facility of administration, oral single dose, favorable benefit-risk balance in HAT patients. Acoziborole can be envisioned as a future tool in the effort to reach interruption of HAT transmission by 2030. So, to treat the sleeping sickness. Thank you. Thank you, Doctor. The last that presentation will be online by Yusuf.
Ensuite, les participants vont commencer la discussion avec les présentations. Youssouf?
Hello, good afternoon.
Good afternoon. You can
Okay.
start. Yeah, you can
Good
start.
afternoon, all. My name is Dr. Amin Yusuf Bashir from Nigerian Institute for The slides are not moving. Can you see my slides?
You can continue.
Yes, we can see.
Okay. They're not moving on my computer. Sorry. Okay. So we all know African tripartite therapies in West Africa is caused by TB Gambianse. In East and Southern Africa is caused by TB rhodesiense. In Nigeria, the last reported case was in 2016. We still have some suspected cases in Nigeria, possibly in Abraka, Delta State, and Bida, Niger State, Nigeria. As we all know, the same Ebola and the vector of the disease has a dynamic life cycle, and because the parasite is intracellular in nature, it encounters a lot of challenges in the host, which it has to overcome in order to survive. And it survives through what we call antigenic variation, that is switching from one BNG form to another. However, before the switching of this BNG across, the old BNG has to be removed for the new one to be expressed. And the cleavage, the removal of the old BSG is caused by an enzyme called mesosurface protease B, which is theoretically cleave the old BSG. So that is why we target that as an antigen for vaccine development. This enzyme, the protein, is located on chromosome 8 as a zinc metaboprotease, and the enzyme is surface localized. We all know chemotherapy is unsatisfactory. Like a lot of my previous presenters have discussed a lot on chemotherapy, also I will just move on. So why vaccine development now? When vaccine development is desirable, because it provides a long-lasting, economically viable option to chemotherapy, production of vaccine, storage, distribution, and administration are simple and easy, and because of the zoonotic nature of TB rhodesiense infection, there is need for an immune intervention. And with that, encouraging results from vaccine development against Ebola and leishmaniasis. So the major objective of this work is to construct a DNA-based vaccine using full-length trypanosoma brucide mesosurface protease B and evaluate its potential as a vaccine candidate in vaccine mice. So this is the flow chart of the experimental design. These are the list of the primers we use. So first of all, we use a new PCR. This is the results of the PCR. We use a PFU Ultra 2 DNA polymerase enzyme, and because PFU produce blunt-end PCR products, so we have to add an 8 overhang required for the TA cloning. So first of all, we lots of clone the gene in PCR protocol gene. This is the protocol. And then after successful cloning, 26 colonies were collected, and we ran a colony PCR, and then the positive colonies were sent and it is exactly, is 100% exactly as the reference Traversoma Brusai Edinburgh 29.1 in the data bank. So after some cloning, we now go ahead and clone the gene in P-back vector. This P-back vector is a modified vector donated to us by Professor Soga from University of Bremen in Germany. The plasmid contain a transgene signal peptide, also a transmembrane signal peptide, and a histag at the end, at the terminal end, for tagging of the purified protein. And you can see the result. The gene was successfully cloned in this PFAS plasmid vector. After that, we send it for sequencing, and this is the result of the sequencing. It shows the correct orientation, and it shows the gene was successfully cloned in the PFAS plasmid. So we now want to confirm whether this modified or recombinant plasmid containing the gene will be expressed if immunized in an animal model. And so for us to confirm that, we have to first of all transfect the recombinant plasmid in M2 mammalian cells. And these are the pictures of the M2 mammalian cells. I cultured the cells for about 12 weeks. Following that, we transfect the cells with this recombinant P-TP MSB construct to confirm it can be expressed. And the results you are seeing show that there was successful expression of the protein. Now, having successfully expressed the protein, we now developed an immunization schedule, an immunization module in vaccine mice. All we use 30 mice. In group 1, we have 9 mice, which we immunize and then challenge with the parasite. In group B, the animals were given NTP baths, and then they were challenged with the parasites. In group 3, the animals were injected with PBS, and then later challenged with the parasites. And group 4 were the negative control that was given only PBS. So this is the immunization schedule. On day 0, we took blood sample for ELISA to detect IgG and interferon gamma, PCB, and the other hematological parameters. And then on the same day, we primed the animals with 100 microgram of the DNA vaccine. And then 3 days after, the same animals were given the first boost with the same dose. 3 weeks again after that, is on day 42, the animal were given the second boost. And then 2 weeks after, blood samples was collected for ELISA and hematological parameters again. And 2 weeks, and on the same day of the blood collection, the animals were challenged with a 2,000 Trypanosoma brucei, majorly strain parasite. So this is the result of the indirect ELISA to assay for the antibodies, and then the result shows that the animals immunized with the DNA vaccine had high IgG response, which is higher, which is significantly higher than the other groups that were not immunized. This is the result of the sandwich ELISA for the assay on interferon gamma cycle which was not significantly when compared with the other groups that were not immunized. So this is the parastemia level. It has clearly shown that the animals that were immunized had milder or lower parastemia compared to the animals that were not immunized. You can see in the blue graph, you can see that the animals also have lower parastemia, and they live longer, at least by 21 days, 22 days, compared to the animals that were not immunized. This is the Kaplan-Meier survival plot to show that the survival pattern of the immunized and the non-immunized animals. You can see the animals that were not immunized at all, and in the negative control, all of them survived 100%. However, the animals that were challenged but not immunized, all of them 100% died by the 30 days. However, at that time, about 18% of the immunized animals survived, and they were able to reach up to 58 days, meaning that they lived at least 22 days more than the animals that were not immunized. This is the change in weight compared between the immunized animals and the non-immunized animals. And the animals that were immunized showed a better weight profile compared to the animals that were not immunized but challenged with the parasite. So in summary, we can say that the TB and the gene from the native strain of the pathogenic strain parasite has a nucleoside of 162 base pair, coding for a predicted protein of 554 amino acids, and is exactly the same 100% with the reference Trypanosoma Edinburgh 927 intraclinic data bank. The TB gene was subcloned and subsequently cloned, and then we were able to purify about 12 milligrams of it, which we use for the DNA vaccine trial. Immunization with this construct was able to induce significant IgG response, but not significant interferon gamma response. Similarly, immunization with this DNA recombinant construct was able to lower parastemia of immunized mice by 75% and 51% respectively on the sample that is first of infection and the peak risk of infection respectively. It also improved longevity of the immunized mice by 22 days, corresponding to increased survival period of 61%. The DNA vaccine also appeared to be safe, as no mouse died during the 8 weeks of vaccination. So in conclusion, I will say this study has demonstrated that the DNA vaccine construct it has a potential as a vaccine candidate, and then because it provides partial protection to virulent T-brucide strain infection in susceptible vaccine mice. This result suggests that this DNA vaccine construct can be used as an antigen in DNA vaccine development against African trypanosomiasis, since it could induce humoral response through induction of immunoglobulin G and confer partial protection by increasing longevity and low parastemia. We observed some limitations during the work. For example, only one immunization trial was conducted, and already the whole trial was laboratory-based, no field trial. Only one route of administration was used, which was intradermal. We didn't use
Donc nous allons recevoir quelques
Going to receive some explanation, maybe question in relationship to the presentation which has been done. We can focus now about the treatment, and it is a treatment which is ongoing in different endemic countries. And for the new treatment on the Cosiboron, and which is now in the process of being accepted, and also the Rhodesians form which is waiting the acceptation of the European agency. So we had also some solution to get vaccine. These are the suggestions where we are going to try to talk before we can go to the other session. Do we have somebody who has a question in the plenary? Thank you very much, Dr. Tambo. It is just two contributions to Dr. Mariam and Dr. Digas. For Mariam, during of her presentation, she could not give explanation that the fexinidazole, the eligibility was not only Dr. Digaza explained later on, and also when we are asking the question to those who took the first treatment and those who took fexinidazole. So some people, they fear, injection, but those who doesn't like, we have also some limit. Children less than 5 years and 20 with less than 20 kilo, they could think that, okay, they are also eligible. It is just a contribution. So in this protocol, we have also to give more explanation to the patient. Dr. Jigas, the title of his presentation was the treatment of THH. It is in the conclusion that he said that although COVID, we treated people with fexinidazole, but in the presentation, we know that the COVID, it is a disease who also made now the treatment to become somehow low. The one which was developed here during the COVID, so the patient can accept the treatment, it was not also talked about. So it is just maybe a contribution. I want people to talk about it. Thank you, Mr. Moderator. I want to go straight to the point. I want to address my question to Dr. Digas. Thank you for his good presentation, but I was not focused. I want to get more explanation about now pregnant women. Thank you, Mr. Moderator. I have a question to Dr. Kolo concerning the efficiency of clozapine. Now, the success he mentioned in his presentation, my question is this. Did we have also some investigation? What was now the timeline for this result? Mariam, please. Thank you. My question is to the WHO. There is a period we are also confronted to a disruptor. We didn't have also the, the medicine, because our patient, most of our patients are at the second phase. So we gave Fexi to this patient. But up to today, there is a follow-up. What is now the WHO advising us? Up to now, we don't have a problem. So what is now the advice of WHO in this situation?
My question goes to Yusuf. I wanted to know why he went for a DNA vaccine instead of a recombinant protein. And then also I wanted to see a data where there's evidence that these mice were having the DNA. Can he do maybe some PCR results to see whether the DNA were really indeed in mouse? And then also, is this DNA going to be integrated in the genome, or it is somewhere there then later is going to be degraded? Because that is the main fear that has been facing people with the DNA vaccine. So thank you.
Another one. The last week. Yeah.
Yeah. Thank you, Mr. Moderator. I would like to know whether the fexnidazole and what's his name? Oxybut, what is the other? Yeah, and the other drug, whether they are purely therapeutic, whether they have any prophylactic activity. In other words, people who get split treated, do they ever get sick, reinfected? Thank you.
On a ramassé toutes les questions et après je pourrais.
We collected all the questions. After some answers, I can give also the floor to WHO, and most of the questions are for Adigas. Then Mariam is going also to give an answer. Because you have the microphone, you can answer to doctor. We have organized two focus group. It was with the adult. We didn't have children. The patient, they were not mixing of patient with the two treatment. The focus group was separated. We didn't mix the two groups. So the answer is not affecting the answer. So they were not in the same group. So they were interviewed separately. So I agree, Dr. Mariam. So I think the children below 14, according to the studies, so the study, most of these children don't accept the result, whatever the situation. So this focus cannot be applied to them. Alors, Digas, you can answer. They ask you 4 questions, and you can now give an answer. Adanas, we have also Roma, who said something. Thank you.
Dr. Enoch Matovu, on the test of the fexinidazole in Tiro de Cienci, I was just asking about the sample size. You talked of having recruited 45 patients. Do you think it's enough sample size to test the drug for such kind, for human use, for that disease? Okay. I was just worried about the sample size. Could it be too small, or you need some further studies before you recommend that drug for use in treating Tiro de Cienci? Thank you.
Ok. Donc Digas commence, après il sera suivi par.
Digas is starting, then Enoch Matovu will follow. Thank you for all the questions. that all my colleagues asked. I want to see what Dr. Onodi said. So we had very limited time. We tried to evaluate, to see all the possibility. We had now to have some online training. So I said in the conclusion, we had also to reorganize the services. And during this time of COVID, we had also to change all our approach to allow even those who are not treated with some also guideline. And the document we received from HWO, thank you for this contribution. According to also for up to now, we didn't have a trial giving also this medicine to pregnant women. We have some of the pregnant women who are also tried. And today we are asked now to make a follow-up to the children up to 24 months. So we could not give it to pregnant women. And if they can take this medicine and the woman is pregnant, we should have also a follow-up. There is also a question asked, according to what we presented here, if it can be also, it can help also treat. Yes, I don't know if somebody can also complete. So the person can have also more information. Please, can you give more information? The question, if it has also the possibility to treat flexinidazole.
It's a drug to cure human African trypanosomiasis, but I don't know, maybe WHO will add a comment because as we know, acoziborol has a very long shelf life, so I don't know, but it's not prophylactic so far. Ok. Il y avait aussi une question de Kuruma sur les rechutes. Bon, c'est quand...
This case of resurgency after 12 months and the third one after 12 months, when we have a white cell, we consider that it is now a resurgence of this sickness. He's supposed to have all these details because he's also a researcher. I think WHO has something to explain in relationship to the last question which you are asking. According to the last comment, Wilfred also gave an answer and we agree. So the indication of the two medicine, they don't also include the treatment. So there is no application inside. After, there was also another question of Mariam, and it came that in Guinea, the stock was not enough, but we had to continue now the treatment. So the recommendation of WHO, and what do we do? In this case, this is what was done exactly. So they use fleximidazole. If we now follow the guidelines, so the first intention and the second intention, so it is fleximidazole. You have to explain that it comes from the data where flexinidazole show its efficiency at the second step by microliters. The efficiency was not enough. That's why the first line flexinidazole, but flexinidazole has some efficiency. So in Guinea, if you don't have, you can alt another medicine, you can use flexinidazole. And Mariam said that, okay, you have to make a follow-up. That is what is supposed to be done, because it has also some efficiency, although it is a bit low. Alors,
Il disappear.
It disappeared. It disappeared.
Okay.
Okay.
Yusuf, you can check. Okay, we can continue.
Okay, we can.
While Professor Caballo, you have something.
Professor, from where? Thank you very much, Mr. Moderator. I have a question for Dr. Enoch Matovu regarding their work on fexinidazole. He reported that there was one relapse out of 45 patients. I wondered whether they considered the possibility of reinfection, whether that could have been one of the explanations. Okay.
Professor Enoch.
Okay, thank you very much. Actually, I had two questions. The first one was on sample size, which really disturbed us a lot. We spent a lot of time figuring out the sample size because you agree with me that Rhodesiense is a rare disease these days. But we put it in the hands of expert statisticians who guided that if we have 34 patients in stage 2 that go out and complete the treatment regimen, they made the necessary calculation that would be sufficient to give us the significance we need. But all the same, we wanted to treat additional stage 1 patients so that we also have insights in how the drug acts in stage 1. Yes, so we are convinced by statisticians that 34 stage 2 patients who complete treatment and follow-up period would be sufficient to give us the answers that we needed. Regarding the relapsing, the carrying infection, yeah, we have made some investigations. First of all, we did some microsat analysis to compare parasites that were present before treatment and those that came back, and we don't see a difference in microsatellite patterns, suggesting that it could be the same population. Secondly, it was typical of a classical relapse where parasites were only found in cerebrospinal fluid. They are not anywhere in blood. So that is further evidence that this could have been parasites that were existing before, but perhaps which were not sufficiently eliminated specifically from the central nervous system. There were no parasites in blood.
Okay. Stephen, we are going to send your question to Yusuf in order to get answer. Okay. Je pense, s'il n'y a pas de...
I think we don't have more questions. We can now congratulate all the presenters.
Last subsession concernant le réservoir animal et...
The animal reservoir. Is Nick around here? We didn't found your presentation. If you can now verify. So you have 10 minutes for this presentation.
Me to present. Oh, can we go back one slide? Here. Okay, thank you. Oh. Thank you very much. This first slide is just, oh. Thanks. It's just to show that it's a collaborative project between ITM, the Department of Biomedical Sciences and the Department of Public Health, and at INRB between the Department of Parasitology and the Department of One Health, and also between the Programme National in DRC. So the project is called Tracking the Animal Reservoir of Gambiense, reactive veterinary screening in Mairi. And in fact, it is part of the larger project which is called the Cryptic Human and Animal Reservoir of TB Gambiense in DRC. The acronym is SHARHAT. And the aim of the project is to reduce the uncertainty about the role of a putative TB Gambiense reservoir in the transmission of HAT, especially in DRC. So the objective of the project was first to develop a novel and improved methods to find back TB gambiense in human and animals. And the second objective was, if we found those animals, if we found those parasites, to compare the genotype and the phenotype of the gambiense strains isolated from these. So the project started already in 2019. And it has been running till, it's still running at the moment. And in the meantime, we collected samples from domestic animals from 5 different areas in DRC. In the first area, in the Haute-Katanga, there we collected endemic controls because it's an area free from tsetse flies. We went to an ancient focus in Congo Central. We went to areas where low HAT transmission in Bagata and Idiofa, and we also looked into the peri-urban exposure in Kinshasa. And we collected animals from, it's still visible. So we have dogs, goats, sheep, pigs, and bovines. No, all my icons are gone, I see now. What we collected from the animals was serum for our serological testing, and we collected whole blood in DNA RNA shields, and skin biopsies from most of them. And when we did our molecular testing of this entire collection of 720 samples, we only found 2 positive for trypanosome. And we used a special PCR for that. It's a PCR based on TBR and 18S, so it has good sensitivity normally, but only 2 out of 720. So it's quite discouraging for us. When we looked into a Gambiense PCR, which used TGSGP, we could not confirm that the 2 samples that we found positive in pigs contained TB Gambiense. So in July 2022, we had an alert coming from Maili, and Maili is a village that is in the Zone de Santé de Kimputu, and it's a village about 800 kilometers away from Kinshasa. And there we had a report at ITM that there was a mini mobile team that has potentially identified 10 HAT cases in that village. And at ITM, there's a larger project which is called Tripelim that allows to record videos to confirm mic observations. And in those videos that we received from Maili, we could confirm at least three patients with actual trypanosomes in their blood. So we immediately decided to try to take in the project, to try to enter the village and try to include the patients in the Sharat project, because we are interested in trypanosome strains. So that meant that we had to go immediately, and within, I think, 1 week after we received the alert, we were already in the field in Kimputu. And the idea was then, okay, it's not really a reactive screening for the people, because normally it's a definition that is used for another process, but at least for the animals, we also call it a veterinary reactive kind of screening. Because once you identify the case, and then you go back and try to identify more cases, but this time not only for the humans, but also to include the animals. and where we went back to Nsongo Maili, we had again the team from the Programme National, the mini-mobile team with some people, with some extra people there. We collected, we performed serology with the rapid diagnostic test of CORIS. We did parasitology with the mic'd columns. And then for those who had an informed consent, we included those in the Sharad study. And as a result, we had all the seropositives that were revisited. I think in total there was less than one month difference between the first visit and the second visit. All those seropositives were reconfirmed. However, from the 3 people that we thought that we saw trypanosomes in the mic'd video, we could only confirm 1. And not by just using the normal mic'd, but we had to use the mic'd buffy coat method. And we found exactly 1 parasite in that sample. We tried to cryostabilize that buffy coat, but in the end, when we did the expansion in the rodents, that ultimately failed. At least this time we had good results from the PCR test, because the molecular tests, out of all the seropositives and the case together, those are 14 people, the PCR test could identify the only case that was there. And this time also our Gambiense PCR, it confirmed that the parasite was present in the case. Oh, I'm lost. Oh, no. This one's... Oi, no. Yes, okay. So considering the animal part of the screening, we again did parasitology, but most of you know that the mic'd, it's a system that very well for human blood and for trypanosome parasites. But if you want to try different blood, animal blood, or other parasites, most of the times it will fail because the matrix is not ready to work with these erythrocytes and with those parasites. So we tried out another method on mic'd to try to apply to the animals, and it's used instead of blood. We centrifuged the blood, we removed most of the plasma, and we respended the buffy coat in the plasma. In the plasma that was remaining on top. And this is a technique that if you could use it, you would avoid to get all the erythrocytes from the buffy coat and from the layer below into the mic'd column. We compared this technique with the normal mic'd. So the normal mic'd is very unsuccessful to do on the animals. But with the modified mic'd, we found that in one of the bovines, we found a lot of parasites. We were all very happy because we thought, okay, now finally we are finding trypanosome somewhere. And in one of the pigs, there were 13 pigs. In the first pig that we examined, we also find parasites. Again, we tried to do cryostabilization of these buffy coats, but in the end, it was unsuccessful. And what was even more surprising is that all the molecular tests, when we did trypanosome PCR or the Gambia PCR, out of 69 animals that we tested there, they were all negative for trypanosome. So were we seeing just illusions in the mic'd? I'm not sure about it, but we decided to test the samples again, but this time for different animal African trypanosomes. And in our lab, we have a new PCR that can be used to just screen to see if you find Congolense or Vivax. It's called it's a cyber green-based PCR. And those that were positive in that test, we confirmed with just the usual ITS region that you would use to separate pathogenic parasites. And this time we saw that in Congolense we found samples in the blood and in the skin of 2 pigs. And one of these pigs was our mic'd confirmed pig, so one of the parasites, so we could determine that likely it was Congolense that we saw. We found Congolense also in bovines, we found it in a sheep. Those are the yellow spots on the map of Maili. Much to our surprise, we could also find back Trypanosoma vivax, and vivax we found it in a goat in the city center, and we found it also in the bovine area in the south of the map. So if you would look at Maili, I'm not sure if this, so this is the city. Here in this area there are the porcheries, or where the pigs are kept. And then here was an area where they kept all the bovines. So we had some lessons that we learned from Maili that probably other researchers already learned a long time before. Because when mic'd positive cases, they can become mic'd negative pretty fast, apparently. That's, of course, yeah, it's a parasitemia. in a patient, and yeah, it doesn't mean that once you have found a parasite that you will necessarily find it again in a couple of weeks later. The good thing was that the mic negatives, they were also negative in the PCR. And a single patient that we found was positive in mic Buffy code. And it was also clearly positive in the PCR reaction. So even with a very low parasitemia, we could find it back. For the veterinary reactive screening, we were surprised that with this modified mic protocol that we were able to find other trypanosomes that were not trypanosome, so Congolense and Vivax. And that, again, we did not find any indication of TB gambiensis. So now we're over 1,000 samples, seven different areas in DRC, and we have not yet found a gambiensis strain there. So was it very useful? I think so, because at least what we did there was to establish a baseline of the animal African trypanosomiasis presence in Maili. And it is nice to extend this investigation in Gambiense Animal Reservoir, where human African trypanosomiasis is found. But I think personally that maybe you should combine it with vector control and then further follow-up sampling for the following projects. So that's our experience in Maili. Thank you very much.
Merci Nick pour la présentation.
Nick for the presentation. I am inviting Traoré for its presentation in the study of the reservoir and the THA in Ivory Coast. You have 10 minutes. Thank you, Mr. Moderator. Good afternoon. I'm Dr. Traoré, and my presentation is about the study of the reservoir Gambiense for a fight for the elimination of this disease in Ivory Coast. In Ivory Coast, the efforts could reduce the number of diseases. Between 2015 and 19, only 9 cases were also observed. It helped now the validation as this disease as a concern in the public. Today, the goal is now to the elimination of the transmission of the disease from now to 2030. But now the reservoir of Gambiense could now compromise our goal. So the prevalence was observed in the also in pigs. And so this context that now a study which took place in the historic focus where the 2 cases were found in 2012, and it was also to identify this Gambiense in the pigs of this locality. Something special in this study. Most of the sites of sampling were chosen according to the kind of, pigs. When these pigs are free, and others who are now they are secluded. So 87 were also free-range pigs, and 70 pigs were also secluded. For the sampling, so also we perceive, and the sample were used for now the test. And for all these positive sampling, so the blood were also in the mice and these with this test. In terms of result, so it will be serology, parasitology, with the the prevalence we observed, it was high for pigs, which were also free instead of those who were really secluded. So our result forecast on the prevalence of pigs who are now free. But now sometimes you can have also all these results if you can consult our articles. The molecule, the cells, these Congolese, which were in the pigs, which were free. So the most found were now had the prevalence of 70%. So observe also the infection in the 14%. The Congolese and the Gabian C was different concerning the trypanolase. The prevalence of 43%, and the different it was Gambians, it was 41% and 27%. The isolation of this so we have 87. So the prevalence for TBI, one sample were positive. The prevalence of 27 were also found. Only one sample were positive, and the PCR, and it was positive to the, and it was done with the Bificot, and also the isolated sample. It was also positive for Olitat. This result is suggesting the also a sample from the pigs which were free. Up to today, it will depend with the spice. And Litats gambiense, which were found in the domesticated animals. So when we consider the result, 50% of the sample were also positive, which is not in also in harmony of the one of these area. This can give a false positive for two reasons. The contamination during the amplification, although the validation of the process by the negative control, the amplification of in conclusion, we can say, even if these tests could identify them in pigs who are free, we can't conclude about this sampling of Gambiense. That's why we have the interest to improve our system of screening to understand now this system. Thank you for your attention. Thank you, Traoré, for your presentation. The next, Jean-Arthur Bida. We don't know if he's in the room or maybe he's representative. We think he's not here. And now we can now give the floor to Dr. Kaba, or maybe the person who is doing the presentation. He's now taking the role of the fight against this disease. Thank you. Good morning. I'm going to present to you the role of this fight in the elimination of this disease. All started with the authorization of WHO to reach this elimination. We had now to replace the program to have the one of elimination. Elimination was also included. So this is a clear vision. Then the team of the research and the fight, they also continue with this vision, with the different also system, and this system were also integrated. First of all, the question which we had now to ask ourselves, how to reach now this elimination. We had now to evaluate now the situation. This evaluation helped also to have three situations. We had also three focus where there were a lot of cases. So this focus, there were also 12 historical focus, and we had also to define strategies to bring the elimination. What was interesting now is endemic focus. There were also an integration by the combination of different activities, medical activities, so fight about this vector. So this is vectorial fight, which is interesting. In other sector, we didn't have this kind of fight. These are now the tools we were using. So it is very important for the monitoring. So concerning this anti-vectorial fight, we had also to do the first study. We had also to make a lot of combination, which also to see how it can also help the transmission. We had also to define the area, which one we were also to work. It could help also to know the density of flies. We had also to do some investigation, geographical, entomological, and also about these cells. So I don't want to go to the details. So what we can see in this zone, and we found we have also some kind of now we had also to identify where to find these flies for pigs and also animals. So what are now the best food for flyers? So this situation can give us to propose some kind of fight. So when we have two situations where these focus are also one on another, we have also to choose So there is a big density of tsetse flies because we have to find also the area where also these pigs are moving, and also they are also interacting with communities.
Et là, nous sommes à Bonon également.
There we are at Egono. So we have a distribution, although we have some areas. Alors,
OK. Donc, même s'il y a également...
although we have also some areas who are not affected, but we focus with our fight in that village. So we can see here almost 2,000. So so the limit of transmission of this disease. And we are doing also some monitoring. So we have also to replace these tools. The impact about these flyers from the beginning, so there was a decrease in the density of flyers. In blue, it is Bono. And we found the impact in the distribution of flyers. It is not very clear. We can see the blue area where we have a lot of density of flyers. Some years later, you can see this map now is very, very now clear. We had also an impact on the also density of the sickness, for we had less and less. In 2000, it was 0 case. And this helped us to reach the elimination of this disease validated by WHO. Now we are entering in another period where the confirmation of the elimination will be done by WHO. So this fight contributed to the elimination of trypanosomias, African trypanosomias in Ivory Coast by reducing the density, and it decreased the contact between and it helped now to limit the transmission. So this helped also to finish this reservoir. How now to maintain this activity? How can that the population can now take this fight like theirs? But now we are working with the official medical officials. So, but now when these officials will go back, we don't know what is going to happen. So we don't know the role of pigs in the transmission of TB Gabriancy. And this is also a challenge. I want to thank all the partners who contributed in the fight of this disease, and we reach now the elimination of this disease in Ivory Coast. Thank you. Thank you, Kaba, for the presentation. And now we go to the last presentation, which will be done by Jean-Mathieu in the impact in the transmission of trypanosome in Cameroon. Thank you.
I am investigator at the IRD, currently working in Guinée with Mamadi Camara. Mamadi, tu m'excuseras, mais cet après-midi, je vais te faire des infidélités. And we will go to Cameroon. Where is Mamadi? Okay, anyway. So I present a work that we are doing with our colleague in Cameroon, especially with Gustave Simot from Chang University, with Trésor Melachio from CREED, and also with Alphonse Achot, that you know as we can still see a trickle of AT cases, especially in Campo Focus that you see here on the south of Cameroon. And so we wonder where are these trypanosoma, because still Alphonse told us that they are running some medical campaign. So to answer the question for this hidden trypanosome, we decided to ask the question, where are the trip in the animal in the One Health perspective, and to look if we can discover trypanosome in domestic and wild fauna, to see if maybe we can detect TB gambiense. We saw that Nick failed to do this, so we'll see in Cameroon if it's different. And if it's the case, if vector control is able to have an impact on this trypanosome transmission. So you see here the work plan, and we take advantage of a 2 years vector control that was run from 20 to 22 to do animal campaign before and after this control, this vector control program. Okay, next slide, it will be easier. So to do so, you can go further. Okay, so I present you the Campo Focus. It's almost as beautiful as Mombasa. It's close to the Ntem River that serves as a frontiers between Cameroon and Equatorial Guinea. It's perfect ecosystem for the proliferation of tsetse fly, and also people raised small ruminants and pig to provide proteins. Up. Wow. Stephanie, thank you for the attention. Okay. Next. I don't want to touch this anymore. Okay, next. So I present you the workflow. So just to join and to have contact with the people who raised. Next one, the animals, and then next one to sample I will mainly present our work with the blood samples. Next. Okay, next one. And to take blood samples, I will present here on the paper the result collected from Watman paper. Next one, and I will present serological and molecular results. Okay, next one. So I decided to present the data before the vector control. Next one, that we publish this summer. So if you want all the data, you can go to this publication of Eugénie Mélanie Kemta that is defending her PhD just this week in Chang. And you can see that we found in all the animal species that we collected, T. Congo, T. vivax, and also trypanosune. And you can see that here, among these animals, 7% of these animals were positive for the TGSGP nested PCR. That is specific for TB gambiense. Next one. So we take advantage of vector control that was conducted by this very boring man named Trésor Melachio. If you don't know him, I think you have to meet him. He's a very interesting guy. And so he was granted by the PVECT project with the LSTM laboratory. And next one, this vector control consisted in the deployment of thousands of tiny targets. You can see here, it's very interesting, the lizard is waiting for the tsetse fly, you see, for the food. And so they were also deployed in the vicinity of the pig fence. So it was running from 20 to 22. Unfortunately, they have to, as people know, they have to cut this program, and for the moment there is no more vector control in Campo. Okay, so next one. So we came back to the field in March 22, and we collected 131 domestic animals. You can see here Eugénie working with Séverin, that is a colleague of Alphonse Achot from the National Control Program. And next one, what we saw, you can see here in red before the vector control, and the result in gray after vector control. This is the serological data done by cats, and you can see a clear trend of decrease of the serological response in all the animals after control in comparison that before. And with the molecular data, next one please. This trend is even more stronger and is significant for the total when you see a decrease of almost all the trypanosome species in almost also the 4 animals that we collected. Next one. It's true that it's important to say that among these 131 animals, we cannot detect any more TB gambiense once more by nested PCR. Okay, and you can see that here we saw this decrease mainly in pig and in goat, and less even in dog we see an increase. Maybe because these dogs are running more in the forest. So we are working on this hypothesis. Okay, last slide. So the take-home message that I want to claim today, I think, is in the line of what Alphonse Achot said yesterday, that this vector control has an impact. So maybe up to now it's not so clear on human, even Alphonse showed us yesterday a clear trend of the decrease of the human prevalences. But interestingly, in animals, we can say that the vector control was effective, and it's like a marker of the effectiveness of the impact of the tiny target in the secretion of TRIP. So obviously, we advocate to continue and to strengthen the vector control in Campo and to spread. I am looking for José Ramon, and to spread this vector control campaign in Equatorial Guinea. As you know, it's focused in Rio Campo, very close to Campo. It is almost the same ecosystem, and Eustáquio Nguema very recently discovered also human cases in Rio Campo. So I think it's very important to do it. And because Kuruma, tu n'as pas montré cette diapositive.
Didn't show that diapo, so it is a do breakout. So we are coming back during the International Day. It was the work which was done by our colleague in Guinea. So now we are ending with this beautiful photo.
À des questions, s'il y a quelques questions ou quelques observations par rapport aux présentations sur le réservoir animal.
I don't know if you have some question on the animal reservoir. Darmas and Amadeus.
Je voudrais m'adresser à...
Thank you, Mr. Moderator. I want to talk to Jean, I thank him for his presentation because it is about this vectorial fight, especially in animals. In his presentation, what they have used, and according to methane target, is attracting more the glossine. What about other vectors who are also in the transmission, especially the mechanical transmission? Dr. Amadou, thank you for the floor. I want to give just a question to Madame Traoré. She was talking about how to take some sample about a trypanosome to dogs and animals. So we have a problem with a certain area in Angola. So we in 3 municipalities, they have identified many cases in the last years. And we found that when we are going to continue with the mobile team, so what is attracting our attention, because pigs in this village, they are attracting a lot of flyers, and they are in fact even in pigs. So we didn't have the capacity to do a complete examination as a molecular biology. And with the kind of sampling we have, can we do simple now test with the microscopy? Is it doable with this trial, maybe to see if pigs, they are also in this, increasing of diseases? Yes, Sarah.
The newcomer is catching up. Mine will straight away go to Dr. Jean. When we are using molecular techniques, we usually explore the use of negative and positive control, so as we can eliminate the effect of false positivity. Did you explore that? And if not, what were the challenges? Thank you.
Okay, Moise.
Merci.
Thank you for giving me the floor. My question is for Dr. Traoré, and I have also to thank her for that beautiful presentation. It is a matter of choice on her studies, and in time or biotope, because this can influence the dissemination of next, Rashid. Thank you, Rashidi, DRC Congo. My question is to the last presenter on the impact. I like very much his result, the way he was also presenting this impact. But now I want to know this result for them. Is it only because of the fight against vectors, or maybe there were also some other factors? You can answer. We can start with Jean-Mathieu. Thank you for your question. I'm going to start with the last. According to me, if you think about a treatment, it was not done. So this study, do we have also some vector had also another impact? So we detected less. I'm not an expert. I don't want also to say something which are not relevant. Definitely, what I can propose you for these sensitive question, you can contact our colleague who can give you relevant question. The other intervening, do you have some question?
Keep it upon. Okay.
Thank you, Mr. Moderator. My question is to Dr. Draman, Kaba Draman. I was wondering whether, apart from vector control, there were other interventions. Because from the presentation he made, it seems as if vector control did everything, but I believe there were other interventions. If there were, what was the proportional impact of each of those interventions? Thank you.
Dr. Draman, tu peux répondre?
Dr. Draman, can you answer? Can you answer, Dr. Draman? Thank you for the question. Yes, effectively, there were several control methods. It was an integrated medical control during where there was screening and then both passive and active, as well as treatment, active, reactive, door-to-door. All those were carried out. But also in parallel to that, the vector control had a role to interrupt the transmission, avoid contact between the human beings and the sessile fly. It was a combined and integrated control. Here, I just talked only about the role of the vector control. Thank you. Professor Ndugu, if you have some comment, general comment about the session.
It's a follow-up to a comment I made earlier this morning, and the presentations we have listened to give more credit to the comment I made. And I think it is also an opportunity for us, as we are talking about driving elimination of heart in a situation where the numbers of cases are very low, and the fact that we also need to mobilize resources, and whether we can use any opportunity that is arising from a One Health approach to still be able to drive that while addressing the animal disease and the vector. The presentations that were made specifically from DRC and the one that has just been made about livestock reservoirs are indicating that there are activities that we could carry out to drive control of the disease. And I'm assuming that when we do the work on livestock, we do not only do sampling, get the parasites, and if animals are positive, we don't treat them. If we treat them, then we are contributing to the control of animal trypanosomiasis. And one of the questions that still lingers is the issue of the animal reservoir vis-a-vis the performance of serological tests. And the question I have is it possible to look at the livestock distribution in these countries and see whether we can relate that with the positivity rate in people when we talk about serological tests? I say this because we go to Uganda, we perform serological tests among refugees who are staying in settlement areas and they are not moving out. The specificity is very high. We see the same in Angola in areas where there is no livestock, there is only people, specificity very high. In areas where we have livestock, we have the human disease, we have the animal disease, the positivity rate for cases is very low, but we still get lower specificity, and whether these are opportunities for One Health approach with a view to mobilizing resources to address some of those questions. Thank you, moderator.
Okay, merci. Je pense avec le commentaire du professeur Joseph Ndougou.
Thank you. With the comments of Professor Ndugo, we can conclude on this session, and we also applaud the different presenters during this session. So we end this session on trypanosomiasis, but I'm going to make a small summary regarding the discussions. We started with the keynote of WHO, which presented the challenges and opportunities on this route of elimination with the reduction of prevalence. And he also gave research pathways vis-a-vis the therapeutic and the issue of engaging communities and the vector control. The second issue was the diagnostic question. And also some implementation. On the on this topic, we talked about new drugs, including fexinidazole, used already in the field, or if we can continue with activities of pharmacovigilance, with the hope that in the near future we shall have also acozoborol, which is a one-dose treatment, and this also can contribute to the process of elimination in the different countries. And with the reduction of prevalence, we raise the problems of community participation of the populations in the different strategies. And here there were some studies in social sciences, qualitative research, which made it possible to understand why the population doesn't participate during this period of low prevalence. Different approaches were proposed so as to see how to improve upon this participation, how to what to do so that communities can participate in control activities against HAT. Then the animal reservoirs, the different presenters did show that we can use the One Health approach, and that vector control is also one of the actions which we should consider besides existing strategies, so as to go towards the elimination of sleeping sickness. So in summary, that was the general report, and the executive committee will perhaps later give this report. I give the floor to the chairman. I wonder if at the level of the assembly there's someone who has another comment to make apart from what has been said. Perhaps WHO, if there's a point which has been overlooked and which we can take into account in the final, for the final report. Doctor? Thank you, Florent. I think you did a very good summary. I think there already you have the basis to start working already on the conclusion for the last session. But I think you did a very good summary. I do congratulate you for the presidential table, which the work done. According to me, there was a very good level of presentations. They were very interesting. I would like to congratulate all the presenters. I think we actually touched on the hot points and more strategic. So I would like to thank all the presenters for the quality of presentations and for the work they have carried out. Thank you. Can we applaud all the presenters of this session? And I give back the floor to the chairman.
Thank you very much. And the moderator and rapporteur of this session are about to retire. So I request you to join me in giving them another round of applause as they retire. So thank you very much. One comment and then an announcement. I don't know whether people are observing like I am doing over the last number of presentations. We have had very new people making their presentations in this conference. To some of us, the old guard, it is very encouraging because it means that the next generation going forward is already holding the strings, and therefore there is no risk that we are not going to have experts on sessile and trypanosomiasis as we go forward. Now the announcement is with regards to the posters. Those of you who have posters, first of all, is to appreciate that you put the efforts to prepare the posters. We encourage people during breaks to go and view them. And for your information, the posters are going to be ranked, and they are going to be ranked by a number of experts, and those that are ranked highest will receive some awards. The experts who will do the ranking, and I'm not saying this so that you go and see them, are Dr. Alain Boulange as the moderator, Dr. Chantel De Beer, Dr. Valerie John, Dr. Joachim Ajakaye, and Professor David Kihorani. So the posters are going to be ranked based on the following criteria. For the others, the institutional affiliation, the addresses, and that will earn 8 points, depending on how these have been done. The corresponding order with an asterisk after the name, that will earn 2 points. That shows who the corresponding author is. If you have done a good introduction and you have stated the purpose of the study, you get 10 points. If you have described your materials and methods very well, you get 20 points. The results account for 25 points. The conclusions and recommendations account for 20 points. And you have put some references, you earn 5 points. So it's simple. If it is simple and easy to read so that you are communicating your message easily, you earn 5 points. And then finally, if you have utilized the space allocated to you, which was 100 by 150 centimeters you get 5 points. So those are the points you'll get. There will be a session to discuss the posters. We are encouraging the experts whose names I have announced to please discuss amongst yourselves. The moderator can coordinate that to agree on how the poster session will be carried out. That's all I have to announce. It is now 4:30. We are requesting that we only take 30 minutes. Within 30 minutes, you will hear the bell. We want you to be here, and after the bell, we shall only give people 5 minutes, and we shall start the presentations. So enjoy your coffee, and please be here by 5 p.m. Thank you very much.